Okay. Hello, hello. Good afternoon. Good afternoon. Good afternoon. Hello, hello. Good afternoon. Hello, hello. Okay. Good afternoon, Gabriella. Thank you. Oh, I missed. Yes. Good afternoon. Thank you. Sorry, Kaya. Good afternoon. And noted that you were very early to the class. Oh, quick thing too. Someone can remind me. I got to open up. You notice I open new portals every time I think of a new way that people are engaging or participating or showing investment or whatever. So another portal I want to open up. One of you can remind me by email or text is I'm going to open up a portal for people that sit in the waiting room for a considerable amount of time before class. I don't know how to define that, but like I definitely know, I just want you guys to know that I know that a lot of you are like ready to go here and waiting like minutes and minutes before I even get here. And it shows investment. I appreciate it. It's not required, obviously, but also it's like maybe annoying for you. So another way to get rewarded for your motivation. So remind me, I'll open up a portal for those of you who tend to be sitting in the waiting room a lot before class, like it's noted and you can get points. Okay. Anyway, so, and that is, for example, Kaya today, I noted. So good afternoon, Kaya. Good afternoon, Gabriella. And I'm not saying it's only Kaya. I'm just saying whatever. Good afternoon, Yaneli. It is often Yaneli too. Good afternoon, Genesis. Good afternoon, Ariana. Good afternoon, Brian. Good afternoon, Sydney. Good afternoon, Erica. Good afternoon, Alfred. Awesome, awesome. All right, good afternoon to all of you. Who did I not say? I think I said everybody. Okay, good afternoon, all of you. Okay. Wait, more people coming. Okay. All right. So. What's the deal with today's class? Here is the deal. The deal is more people are coming. Okay. The deal is, the deal is, okay. The, de the deal is more people are coming. Oh, sorry. Not what I meant to do. Okay. Um, hello. Okay, so the deal, what, my screen is frozen. Don't look at that. That's an answer. Don't look at that. It's a giveaway. It's a spoiler alert. But wait, why is my screen frozen? Why is my screen? It's really weird. Okay. Okay. Oh, there's like a big, what do you call that? Latency. Okay, so what's like happening today? Well, okay, a couple of quick reminders at the risk of being redundant, but I just want to be super clear. Like as I think you and okay, we're talking about exam today, okay? So I'm hoping, even if I'm hoping that everything I'm about to say is old news and is already clear to you, but I just want to be as clear as possible. So if there's any concerns or questions, you're going to put them in the chat like now, or you're going to email me or something. Because just to remind you, tomorrow night, no later than 8 p.m., maybe a little bit earlier, I will post the exam. I know it's Halloween. I apologize, but I will post your exam tomorrow night, right? It it will look very much like the practice exam that you've had in your possession for a while now. It'll look very much like that. It won't be identical. Like numbers will be changed and stuff like details will be changed. You'll have to pay attention. Don't, but it will be very similar in format and content and all of that. It will definitely not be longer than your practice exam. There will be nothing on your actual exam that isn't somewhere in the practice exam. So the practice exam is a comprehensive sneak peek at the actual exam. The actual exam may well be shorter. Like maybe there will be some things that are in the practice that aren't on your actual exam. So the whole idea is if you know everything in the practice, you're set. It may be shorter and or it may be that all of those problems appear, but I give you choices like you do this one, you have to do this one, but then you do this one or that one or something. So in the end of the day, you're not going to solve as much as that practice exam and you're not going to solve more than it. I hope that's clear. Okay. But your exam will be very similar to the practice. Then you have all weekend to do it. You can do whatever you want. You can use the web. You can use all my old videos. You can use Khan Academy. This is not a paid advertisement, but whatever. You can use like whatever resources you want. You can use one another for help. And in fact, you should, right? You could do whatever you want during this weekend, particularly in order for you in your way and in your time to construct a like rough draft of your exam, your final exam document. And I'm highly recommending this, that you put together a draft of what your exam is going to look like with your friends and so forth, right? But then somehow you're going to leave yourself time, Sunday night or whatever, you're going to leave yourself time to finally, at some point, sit down by yourself and write out neatly and clearly and thoroughly and confidently a final copy of your exam with your name on it. Even while you're doing that, you can still be looking at other things. I'm not saying you can't, but by the time you're writing down a final copy of your exam, then by that time, it is going to be a thorough presentation of your authentic understanding of all the concepts and steps and thought processes that it takes to get from the beginning of a physics problem to the final solution of a physics problem, right? Your final exam document, which is going to look very much like the way you've been practicing on homeworks, like your final exam. Again, this is just reminders, but I want to make 100% clear because you've never taken an exam with me before. It's a slightly, maybe unusual format. And everything I'm saying right now, to be clear about what I expect from exams, for the record, is the same thing that I'll expect for the final exam and the same thing that I'll expect for the midterm and the final in Physics 204, if Quark willing, you're still with me for that class. So, so this is an investment in the future to understand this. That eventually you're going to create a whole final document with your name on it, which walks me through as extensively as possible all the steps and mini steps it takes to get from the beginning to an end of a problem. You're going to use the 5-step method, like reminder right here on the screen. You're going to use the 5-step method as the skeleton for what you're doing. Like at a bare minimum, you're doing the 5-step method. If you're wise, you'll label your steps as you go. For every problem, you're going to have a diagram and the facts, and then what is the question clearly, and then the print, then definitions and principles and etc. And you're going to walk all the way through it and then box the final answer. And all of this is going to be on blank white pieces of paper that then you scan in and make a PDF or a Google Doc or whatever. And you're going to make sure that what you finally have at the end of the day is a self-sufficient document. Like one way you'll like a blue book, right? Like you're not photocopying my questions into your document. You're not copying and pasting them. You're not including my questions in your document. On the one hand, you're not. You're like giving me, in effect, a blue book, But on the other hand, you're giving me everything I need in your full, thorough, neat document. You're giving me everything I need to follow everything you're doing. That is, you're making each question fully explicit in your words and in your way, so that I'm just looking at a big document of physics. I don't have to look at the original questions, and I won't. Like, I don't have to be flipping back and forth between 2 reference guides or something like that in order to follow your work. You're giving me a self-contained document of physics that walks me through full solutions for all the physics problems that you're solving, right? And everything, all the understanding that you're conveying, you might have only acquired this weekend from your friends. It's not too late. Like you might have been confused for the last 2 months and somehow it's all coming together this weekend. That's fine. And you're not doing citations. You're not saying, and my friend told me this or that friend. Like, no, I don't care. No one's claiming that they made up physics, but you're not cheating in the sense that everything that you're writing down is something that you understand. Anytime you write something down, it doesn't matter. It's not good enough for it to be true. It has to be broken down into such tiny steps of explanation and justification that it's clear to me that you understand what you're doing when you do it. That is your goal in this document. Again, I'm not trying to stress anybody out. I just want to be really clear. You're not just giving me answers. You're not even just giving me bare bones steps. You're giving me a full presentation of your evolved understanding. You're communicating through your evolved language of physics to me and showing me how to walk through a physics problem. In effect, you're teaching me the physics, if you want to put it that way. So more is better. Like err on the side of over explanation, err on the side of many colors, err on the side of thought bubbles or equations here and commentation and commentary over there. Err on the side of lots of English. It's not just numbers. It's explanation of any kind as you go, right? One of the ways you'll know that you've really developed an understanding of this material and that you're giving me a really good exam. One way you'll know is, well, first of all, if you label all the steps. Like, remember that the 5-step method is a grading rubric. Like, what I'm looking for as I go through, I'm not looking for correct answers. I'm looking for steps. And if all the steps are there, the answers are going to be correct. But I'm looking for steps. So if you keep labeling as you go, here's step 1, DFP, here's step 2. The more you label as you go, the more you're making it easy for me to find all the places where you deserve all the points. You're practically grading your own exam the more you label it as you go, right? Make it as easy and inviting on the reader as possible. Honestly, so your exam, if you do this right, it's going to be long. I'm not trying to scare you. But like if you just hand in one page of a bunch of answers, something is not right somewhere. Or if you hand in 2 pages where you do a bunch of stuff, but it's so crammed in, it's like so compressed and like lines aren't skipped and it's so tiny that it's like really hard to follow and really, that's not a good idea. You want to make this an inviting presentation of your work. That's why I'm saying again, do a rough. You could say I have bad handwriting or this, that, but then take your time and do a rough copy first, like with your friends. And then when you do a final copy, you'll know that you really are doing this well. First of all, if like there's labeled steps like everywhere, but second of all, you'll know you're doing this well. If by the time you're doing a final copy, or even if you know that you and your friend have worked together, or your friends have worked together, and you have all the same answers, but your exams are starting to look really different from each other, that's a good sign. That means you are really doing this right. Because by the end, the more you actually understand what you're doing, the more different your exam is going to be. Just like some of you already had 2 different physics professors, right? 2 different physics professors are getting all the same answers to all these kind of things, but our notes look totally different and our lectures look totally different, right? Because we're fluent enough in the language that we're speaking the language in our style. That's what you want to get to that point. Okay. I'm explaining this again, but I'm just reminding. That's what you're looking for. The more you understand this material, then the more you're going to explain your understanding, the better you'll do. The less you feel that you understand the material, the more you better explain and the better you'll do. The more you want to break down authentically what you're doing, the better you will do, whoever you are. Okay, so you're going to turn in your final, and if there's any questions, again, this is a slightly unusual, like you can, right? It's open universe exam, but I'm grading it based on everything I just explained. So make no mistake, even with this open universe exam, I always get a bell curve. I mean, like people get, I'm not, anyway, you get my point, but logistics, you turn in the exam by 12:15 on Monday, right? You're going to turn, and it'll be a PDF or a Google Doc, and it'll be not short. It'll be a number of pages. You'll turn in the thing by 12:15 on Monday, and you'll show up to class. That's like part of the exam experience is you turn the thing in by 12:15 to Google Classroom. You show up to class like you always do on Zoom, right? It won't be a stressful class. You can breathe out during the class. And if there, and I am serious about that, it's not like a homework, it's an exam. Like it has to be in on time. If there's any, if you anticipate any issue this weekend at all, like a medical issue or a family issue or a psychological issue, you don't have to decide in advance what I'm going to think about that issue. You communicate with me in advance. Like if something is happening and you're anticipating there's going to be an issue with you getting this exam on time, reach out to me, let me know the situation. I'll see what I can do. I mean, it depends on the situation, but I will work with you one-on-one. If you have a one-on-one situation, reach out to me one-on-one. We'll see what we can do. Even if I can't perfectly accommodate you, even if I have to say, well, I'm going to have to take 5 points off your exam, but okay, at least you've warned me, so it'll just be 5 points. That's what'll happen. Like what you don't want to do is surprise me on Monday. If something comes in on Monday late and I have no warning of that, and I didn't see that you anticipated that at all, that is not a good situation for you. So if you think there's going to be an issue, let me know. We'll see if and what we can do. It'll be definitely better to let me know than not. Okay. Okay. So that, okay. Um, Other than that, during the weekend or whatever, I can't help you with the exam. But if you think there's something unclear in a question or something, I mean, you can help each other. I can't help you because that's not fair. I mean, I'm not, but during the weekend, if you think something's unclear in a question or I possibly made an error or something, that's certainly possible. So reach out to me, say, Professor, I think you're missing something in question 4, or like, I mean, is this whatever. If you, then and if you're right, if I made an error or something's unclear, then I'll answer you and I'll post it to everybody. Okay, so you could do that. But other than that, I can't. Okay, that's just all the logistics. Okay, I think that's it on logistics. So what we're going to do now well, first of all, let me just raise your electronic hand. I know this is all boring, but is that all clear? Do you sort of get what to expect for this exam? Thank you. Thank you. Awesome. Awesome. Thank you. All right. That's like 8 here. All right. Great. Thank you. So what I'm going to do now for this last period before the exam is we're still going to prep. Like I'm not doing new material or something. We're going to prep. What's going to happen now is, first of all, if any of you has any concrete or specific question at all about anything in the practice, like I'm sort of hoping you've looked at the practice. I hope you've looked at the practice document by now. If you have any concrete or specific or focused question about any detail of the practice exam or the rules or the expectations, this would be a very good time to ask. If you just want to say, like, Professor, can you walk through problem 5? Well, the answer is maybe. I'll tell you about that in a second. So, but that's a very big question. That would take like the whole period, right? But any small questions that I can do concretely in a minute or two, this would be the time. So if you have any specific questions or clarifications from anywhere in the practice exam, this would be a time to ask them. And I'll pause for a second, like in the chat or the direct chat. So if you have any questions right now about exam expectations or about the practice exam, this would be the time to ask. Okay. Now, as far as the practice exam, again, your exam will look very much like it. So the practice exam, I walked through a big chunk of one problem last Monday. Somewhere in the YouTube channel, like if you do enough poking around, you'll find a walkthrough. You'll find that I've solved pretty much every one of those problems somewhere in some video. So they're all out there somewhere. What I'm going to do now today, if you don't have any specific questions, is I'm going to walk through one more problem in the exam. So you will have seen a total of 2 out of 5, like live in synchronous time, and the others you can find unlive, asynchronous. But I'm going to say this too. In mind, I know which problem I think would be most strategic for me to solve for you right now. If there's no questions, I'm going to walk through a big chunk of one of the big problems in the exam right now. But I also want to make clear that in the section that just met at 10:50, the other section of your same class, I also walked through a problem. I'm going to deliberately walk through a different problem with you. So my highest recommendation is, like, obviously pay attention to the problem I'm going to walk through for you right now. And then of course I'm trying to explain it. I'm giving you an example of how to present it. You would be if you go to solve that problem on your exam, you'd be very wise to watch this video again or whatever, take very seriously how I do it, and show that you've seen how I did it, but don't do it exactly. I mean, don't just copy my words. Believe me, I'll know if you did. Don't just literally copy use what I'm doing as a sample solution, of course, and then understand it well enough, like try to do it on your own without looking a couple of times. Then you'll know you really get it. And by the time you turn it into me, it'll be the same answers as I'm getting, or with different numbers, but it'll look very different you doing it if you actually understand it. Okay, I've said that enough. So I'm going to walk through one of the problems now, but what I want to make clear to you is I walked through a different problem in the other section on purpose. So my biggest advice when you're sitting down to do this exam or prepare for it, at least on Wednesdays, if you're rerunning through today's class, like on a video, also watch the other section, because in other words, there's like 5 problems on this exam, right? Monday, I walked through one of them. today, right now with you, I'm going to walk through another one. In the other section, an hour ago, I walked through a different one. So if you watch both videos, you'll see 3/5 of the exam right there. Okay. Please understand I'm intentionally doing two different things in the two different classes so that you have the benefit of two different videos. I hope that's clear. And in the P and what I did in the other class is already all. So I did in the other class, in other words, I did the without a paddle problem. And here's all of the notes from it are going to be in the PDF that I'm going to give to you. Okay. So that's what I did in the other class. It's all in the PDF. Now with you, I don't know why there's such a lag on, I'm a little concerned about the lag here, but with you, I'm going to start right now. If there's no questions, I'm going to switch the screen share. I'm going to start. Hold on bear with me for a second. I know you can't see the other screen right now. Hang on one second. Or yes, you can. Wait. Okay. What I'm going to do with you right now. Is there something in the chat? No, there's nothing in the chat. Okay. I'm about to solve for you the problem on page 7 of the practice exam, the problem called the Yaver Bomber. I'll screen share it for you in a moment and then I'll solve it. But I just want to, could you please, if it's clear to you that in the other class, I did the without a paddle problem and that will be part of your PDF, but you should watch the other video if you want to see that problem solved. Just raise your hand if that's clear. Great. Awesome. Thank you. Okay. Awesome. Thank you. Okay. Awesome. So for now, for you in real time, I'm going to just switch the screen share for a second. What I'm solving for you right now is this. Yes. Okay. Um, this problem is so I'm trying to solve like what I think are sort of the hardest. Like I'm not anyway, this problem, it seems very intimidating. It seems out of nowhere. Like, have we ever solved a problem about a plane and an Atlantic Ocean and all this stuff? It seems like what kind of problem is this? But first of all, the first warn, as it says, this is really lab 4 dressed up. It's all the same concepts as lab 4, which is to say, this is another one of these problems where things are happening in 2 dimensions, but the way to analyze it, to understand, is to solve 1 dimension at a time. Like, remember that every 2-dimensional problem in physics is really 2 one-dimensional problems occurring simultaneously yet independently. That's like the underlying principle behind this problem. So if you understand that, you can solve it. And that's the underlying principle behind lab 4. So you'll know you really get, if this just looks like a completely random, like out of nowhere problem, which it might at first, if it continues to look that way, even as you're doing calculations, you're probably not in as strong command of it as you want to be. You'll really know you get this problem when you start realizing, oh, this is what was happening in lab 4 conceptually. Then you'll know you know something. Okay. So this is what I'm going to solve it now in a minute. This one. Right. So this is the situation, right? Similarly, one of the reasons I'm not in either class, I didn't walk through the whole coyote roadrunner problem. Now, again, there's videos on that you can find, but the reason I chose not to literally walk through the coyote roadrunner is once you get to the point of seeing how all this material is connected, I hope you'll realize that coyote roadrunner problem is literally the big old duck problem turned on its side. It is the big, I mean, it's a coyote instead of a duck, or it's a this instead of a that. And it's turned on its side, if you know what I mean. But again, all the concepts, all what it's asking, and all the equations and the methods are literally the methods that you use for the big old duck problem. So the more you see how all these things relate, the more you're on top of the material. At first, it doesn't seem that way, but that's what you're trying to get to. So anyway, so that problem, if you're trying to understand it or practice it, the coyote one, that's big old duck. This one is really lab 4, but here we go. I'm going to solve it now. and I'm going to try to walk you through my version. I'm going to try to walk you through a 5-step method version of it. But again, please know if you're still paying attention to me, like I'm giving you a sample solution. It would work. It's an example of what I'm looking for. If yours doesn't look anything like mine or doesn't benefit from mine, then something's probably wrong if you're just writing down raw answers. But on the other hand, if yours looks identical to mine, or you just copying down literally what's in my PDF, then something's wrong there too. Your goal is to understand this well enough to make it your style of presentation and explanation. The more explanation, the better. Okay, so I'm going to okay, last time. Just I know I'm over talking. I'm going to switch screens and start well, I'm going to I am switching I'm going to switch screens and start solving. I'm going to try to switch screens. Okay. Okay. Okay, so just one last time, just raise your electronic hand if you're with me, if you know what I'm about to do, if it's clear what I'm about to try to do for the rest of the period. Great. Thank you, Kaya. Thank you, Yaneli. Thank you, Sydney. Thank you, Genesis. Awesome. Okay. And 7 others. Okay. Awesome. All right. So I'm going to, okay. Awesome. Thank you. So here we go. Okay. Awesome. Thank you. So I'm going to solve the problem. I'm going to do the 5-step method. And also, and I'm going to try to like say pro tips as I go. I mean, I know this is never like an exciting fun class, but if you can pay attention as I go, I'm trying to give you as much strategy and advanced warning of what I'm looking for in the exam, as possible. So I'm going to do the 5-step method to solve this problem. One thing I want to say right away, there's a lot of information in this problem. It looks like a very new, complicated problem. I mean, it is, right? But one advice is, yet all the information that's given you eventually need, but you don't all need all the information all at once, all the time. So don't try to take it all in, just take it in one step at a time and use things when you need them. So, okay, so first I'm trying in step one to set up the diagram and fact pattern, like the situation itself. So, sorry. Okay. Okay. So first, as best as I know, is there anything other? All right. I mean, there are a lot of facts in this problem, but basically you've got this plane that's going to I mean, this airplane that's flying to the east. Hold on, I'm just switching the view on the screen so you can see if there's something in the chat. Okay. Plane is going east. We don't know that a plane is flying a constant velocity east. Oh, I think it does say constant velocity, right? It's got it. Sorry. Yeah, constant speed. It does say that. So that's a fact. That's an important fact. Like the speed, whatever it is constant, is the same as its initial speed. So it's going to the east at a constant speed. It's 125 meters above the ocean, above the surface of the earth. It crosses this tower. The tower is just like a reference line or a reference point, and 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 um and it crosses the tower. And the two facts we're given that are in this picture is the plane is a certain amount long, 8 meters, and we're told that like when the front of the plane passes the tower, then it takes a tenth of a second before the back of the plane passes the tower. That's kind of like in lab 4 saying the front of the marble passes the photo gate, and then later on the back of the marble passes the photo gate, and between the front and the back it takes a certain amount of time for the marble to get through the photo gate. Or I mean, that's what the photo gate is telling you in lab 4 do if you use one photo gate, right? So that those are facts of the problem. Tacitly, what I'm really saying is those two facts, 8 meters and one tenth of a second, put those facts together, and what you're really being told is how fast this plane is traveling. I hope that's clear, or we'll find out that that's clear in a minute. Um, and right when it passes the tower, it drops a bomb, bomb number 1, right? I mean, I probably should put that in the diagram. It's a little difficult, but I guess I'll say bomb number 1. Well, that's a little confusing. I'll put it. Well, it's a little hard for me to put in the diagram because it doesn't happen until the plane gets to the tower. So I'm going to leave it. But anyway, you'll figure out a way to do your diagram should capture the same information as mine, but it should not look like mine, right? And you have to have a diagram. But that's a sample of my diagram or my situation. Um, so that's DFP. That's step 1. Again, be err on the side of being more detailed. Say more, not less. Anything that comes into your mind as an issue, write it down. Or as information, write it down. But that's my step 1 DFP. Then step 2, what, and I'm labeling my steps as I think you should. Step 2, what is the question? All right, well, there's different questions, but let's do question A. And by the way, okay, also I'm going to say, I know there's even more information in this problem. Like it starts saying all this stuff about like elevator cable snapping and freight elevator. That's important. I'm not saying that's not important, but I'm just sensing reading all of this that information is going to become important later. So I'll deal with that later when I need it. But right now I'm dealing with the information that I need. Okay. And that's a test taking strategy. Because I can't even in my brain hold all this together any more than you can. But all right. The question is, right? Put it your way, but this is the question being asked in part A. It's asking from the moment that, so if you let t equal 0 mean the moment that the bomb is released, we're asking how much time elapses before that bomb hits the ground. Now, notice right away, there's all this other information in the problem, but I don't need all the other information for that. I'm just looking at the bomb going toward the ground. So what principle am I using for this? Like well, the first principle is that I'm ignoring all the other stuff. The first principle is I know that the airplane is moving horizontally while this is happening. There's like all this other intimidating information in the problem. An airplane is going forward, and then there's like things with an elevator cage and all that. But every two-dimensional problem is really two one-dimensional problems happening simultaneously yet independently. In other words, the amount of time it takes a bomb to get to the ground is just the amount of time it takes for you to drop something from a height of 125 meters until it hits the ground. I only have to examine the y-axis in order to solve this question. So I want to make that clear. So step 3 GDP, and I would go a little bit crazy on this, right? Not crazy. I'd be a little excessive on this. Step 3 GDP. I would write something if I were you. I would say, first of all, the principle we're using is Galileo's principle of relativity. I would say something like that. Right now, I'm going to the next page. And a pro tip or recommendation, I would say something like this too. Okay. Okay. Again, for those of you who are still paying attention, I'm giving you examples here. Don't copy my exact words. What I'm suggesting, like the principle that you're going to use to solve part A of the problem is Galileo's principle. I would suggest that you make it clear to me that you know that Galileo's principle can be expressed many different ways. We already have 5 different ways of expressing this principle. If you are following this course, you realize that each time we introduce a new topic or a new chapter or a new kind of problems, each time we introduce it with a new form of Galileo's principle of relativity. Like the idea behind physics and or the way we do physics is that it all comes back to Galileo's principle of relativity. It doesn't seem that way at first, but ultimately, every new equation or a new concept or new topic is just another way of expanding or extending or or understanding Galileo's principle of relativity. In other words, we already have 5 forms. You're going to get like 4 more forms by the time the semester's over, and more in Physics 204. Each new chapter is another form of Galileo's principle of relativity. And more you see that, the more you see that all this material is connected by that principle, the more you're really understanding physics, and you're not just memorizing math equations. So what I would do here in the exam, I would say something to that effect, like, okay, there's this principle called relativity. It can be expressed many different ways. The main principle, I would say, if I were you, I'm not doing it for you, but I would say, like, form number one of the, like, find it in your notes, like the original form of the principle is something to the effect that the laws of physics are the same in all constant velocities. Or sometimes we say in all inertial reference frames. Like even that, there's different ways to say it. And if you play the video from the other class this morning, or you look back at the PDF, I talk about it a lot over there. But I would say something like the principle is this, maybe even give your own example, maybe give a little illustration. Like you're trying to dazzle me with your evolved understanding of physics. So pause for a minute here on the GDP and say, here's the principle, here's how it works. And then say something like that you can, or you can choose or not to explain all the different forms if you want. You can lay them all out. If you think you're going to use different ones at different parts of the exam, lay them all out, great. And or cut to the chase and eventually say, now the form that is applicable directly to this problem is form number 5, right? And form number 5, let me remind you, is right. So say something to this effect. Again, it will be slightly different words by the time they come out of your mouth, but or on your paper, but say, like every two-dimensional problem in physics is really every two-dimensional, problem in physics is really two one-dimensional problems occurring at the same time, but independently of each other. I would pause there and say what that means in your words, or say what it has to do with this problem, or give an example or something, right? Like expand, explain why that's relevant to this problem. Uh, right. So but I'll tell you, like, now I'm still in step 3 here, right? I'm setting it up conceptually. Oh, what just happened? Sorry. Okay. right? So I'm saying very much in why my words here. Like, here's another pro tip. Like, hopefully you understand the concept that I'm saying here. I mean, I'll read it out loud in a minute. But like, if your words are exactly the same as mine, that would be a bad idea because my words aren't even that good this time. They're very awkwardly Yaverbound-ish. Like, you want to put this your way. But what I'm saying is you got this plane going home. Well, okay, I'll read it out loud. It says the amount of time a bomb will take to fall to the ground from a plane flying horizontally depends only on the kinematics of free fall. Okay, I'll put it better. Depends only on the kinematics of vertical free fall. I'm trying to say here. You got this plane going horizontally. You've got this bomb falling out of the plane vertically. Like two things are happening at once. A plane is going like this, and a bomb's falling out. What I'm saying here is, even though both of those things are happening at once, even though they're happening in the same amount of time, they're not affecting each other. They're independent of each other. So if the question A is asking how much time does it take the bomb to fall to the ground, even though the bomb is doing something weird, it's like coming out of a horizontal plane, it doesn't matter. The amount of time that it takes for the bomb to get to the ground is exactly the same amount of time it would take if you just stood at that height and dropped a bomb. That's what I'm really trying to say. In fact, pro tip, I'm not even going to write this down for those of you as a reward for people who are still paying attention. If you were to write on your piece of paper now, example, whatever amount of time if you write something like the amount of time it'll take the bomb to fall from this moving airplane would be the same amount of time as it would take a bomb to just be dropped from that height. If you write something like that down, then you'll really show me that you really get what's going on, especially because I'm not writing that right here. Do you follow me? Like, and this is the principle of lab four. Lab four, to say this really quick, and you maybe even say this in your notes. It's like, as in lab four, when we tried to predict how far back to put the gun, so that the bullet like landed on the target on the floor or whatever we were doing. Like, in order to calculate the amount of time it took the ball, the ballistic projectile in lab four, in order to calculate the amount of time it would take the ball to get from the table to the ground, we did not take into account the firing speed of the ball, right? That's the whole point of lab four, that the amount of time it takes the ball to get to the ground is just the amount of time it would take if you just dropped a ball. That's what we're saying. Right. I'm going to say it one last way because it's such a big physics principle. I'm literally saying that if I stand at a location and I have a gun in one hand pointed horizontally and I just have a raw bullet in my other hand and I fire my gun, and so a bullet comes whizzing out at a super high speed and goes really far before it like falls down and hits the ground. Whereas this other bullet, I just release from my hand and just drop. If both of those things start at the same time, if I squeeze the trigger and drop a bullet, even though one bullet's going to go way far and arc down and eventually hit the ground, and the other one is just going to go straight to the ground, I'm claiming to you both of those bullets will hit the ground at the same time. Like, that is the principle that's going on here. In fact, I'm screaming now because I'm deliberately not writing this down. If you are with me right now, your reward for being with me right now is if you write that down in your exam, you'll have to be in your words because I'm not writing it. If you write that down in your exam, like if you say the principle here is the idea here is a bullet, or make up a different example, like two baseballs, whatever, that one dropped and the other draw a diagram. One dropped, the other fired. They'll hit the ground at the same time. That is what we're saying here. And that is what lab four is based on. And why is that all true? Because of Galileo's principle of relativity, it says this axis may happen at the same time as this axis, but they don't affect each other. Okay, that's enough, but that's the point. Okay. So that means now, one last thing to write. I'm still in step three. I haven't still in step three here. Okay, this is still step three GDP, and I will obviously, I know there's 23 minutes. I'm going to start speeding up more now. Again, in your word, basically, I'm saying my other step three GDP that I would need to solve this part A is an equation like the one I just wrote at the bottom. Like so you put it in your words, but say like now we're going to basically I'm saying now we're going to deploy constant acceleration equations because in the vertical axis, in the y-axis, we have constant acceleration due to free fall. Maybe say that too. Say that whenever something is free falling, it travels at a constant acceleration. Therefore, the constant acceleration equations apply, right? And they apply one axis at a time. So like I'm applying it to the y-axis. So I'm putting these little y-axis subscripts on everything I'm doing, right? Like that. Okay. And in the initial place that it falls from, we'll call 0. So that's my equation, right? So now I can start solving for this problem. Oh, sorry. Okay, a couple of things. So first of all, and I probably should have done this back in step one. If you're paying attention right now, maybe the thing I'm about to say you should put in step one. I'm defining down to be positive here, at least in this context. I'm saying down is positive. I could do whatever I could say it's negative, but I'm saying it's positive because the bomb is just falling down. It's never going up, it's just going down. So I want as few negative signs as possible always. So if it's just going down, I'm going to call that positive. Therefore, the constant acceleration due to free fall due to gravity is approximately 9.8 meters per second squared, which I can round to 10. Always in an exam you can, unless told otherwise. But I'm calling it positive 10 because I'm saying down is positive, right? And V naught Y, the initial velocity in the vertical direction, the initial velocity in the vertical direction is 0. Hold on, I apologize. I have to leave for a second. I'll be pardon me, take a quick coffee break for a second. I'll be back in 2 minutes. I'm pausing the recording. I apologize. I'll be back to the recording. Okay. And I know we have 16 minutes left. All right. What I'm saying. Okay, this is an important part now, right now. I'm just about to plug into the equations. And if you notice the pattern, let me pause for a second also. I mean, let me pause what I'm saying and say, notice again, Monday, we walked through one of the problems of the practice exam. We did the 5-step method. I give you a sample solution of how to do it. I think it's a very hard problem. I don't think it's easy, but if you sit and study what I did, you'll eventually understand it and be able to do it yourself. But notice that that example on Monday was very computation heavy, right? The problem from Monday, adding two-dimensional velocity vectors, when we do the 5-step method there, it looks very mathematical, like especially like steps 4 and 3, a lot of math. And again, pro tip for that, like if you have, by the time you're done with that type of problem that we did Monday, if you haven't drawn at least 4 diagrams. Like if you're doing that problem correctly, you're putting 3 vectors together in one diagram, then you're taking 2 separate vectors and breaking them up into their own right triangles. So that's like 2 more pictures. Then you're doing a chart and adding together the components that you got from those 2 triangles, and you're making one final big right triangle. So you would have at least 3 right triangles and a non-right triangle and a bunch of computations and a chart in order to do that problem that we did on Monday. And that's all within the 5-step method. Now, today, just to be clear again, especially if we run out of when we run out of time, I'm still doing the 5-step method on a different problem. But notice here, I'm spending a lot of time talking and a lot of time writing English, a lot of time on like step 3 and setup. This problem, the computations are not that heavy. This is more of a conceptual problem. It's still the 5-step method. And in both cases, it's still Galileo's principle of relativity. I know that when we first introduced that in videos and stuff, a lot of people were saying, like, I get it, I guess, but like, I don't see what this has to do with solving problems. I'm trying to show you now that we're at the exam. Any problem you solve, amazingly, it has a lot to do with Galileo's principle of relativity. We are using Galileo's principle of relativity directly to solve these problems, but some problems are more computational and they look like math, and others are far more physical, conceptual, and they don't, and the math is not the hard part. By the time, and that's why I can spend all this time talking, and I know I only have 13 minutes left, but by the time I actually get to the computations, there's not that much computation to do. I'm trying to encourage you to see that. This is a physics class, not just a math class. I mean, you have to be good at math, you have to like, learn math, but math is just the language, it's not the content. And so to explain things and work things through in physics, a lot of time that involves a lot of pictures and a lot of words, as your exam will, right? So back to this now. The equation is that straightforward equation. And so that the converse of that means don't just think that if you've memorized the equations or something, you're good to go. Because I'm giving you the equations anyway. It's not even worth memorizing. All right, you understand what I'm saying. So here, the equation is like y equals 1 half at squared plus v naught t. Like the acceleration that we're going to plug in is the acceleration due to gravity. The initial velocity is 0, right? Because we're in the y-axis right now. There is no velocity. Like the bomb is just dropped. I know it's moving forward, but that's not relevant yet to this. You get my point. I hope, but here, like okay, I guess my pro tip or what I'm saying is, like, explain. Um, Last pro tip too about this. Anytime I say explain, if you're wondering, well, what am I supposed to explain? Like, I get it. Like, one thing that, well, I want to go off on this. Basically, what I want to say is anytime you don't get something, try to remember that feeling. Like, especially if you look at a problem and at first it's all just, I guess I talk about this in the other video, but bottom line is, this is again a tip for people who do feel like they understand, for those of you who do feel like you get it, but also for those of you who are not sure that you get it, whatever it is, whenever you move from not getting it to getting it, it's that evolution that you want to share with me. When you move in your mind from it feeling fuzzy or feeling wrong to feeling clear and correct, that's what a proof is. A proof moves us from not full understanding to full understanding. If your exam is like a big proof, then that's what you want to do. So whenever I say explain something, like explain why V naught Y is 0, really secretly what I'm kind of saying is explain why someone might not think it's 0. Try to remember the time when you didn't think it was 0, when you thought, well, the plane's moving forward, so it has some velocity, right? Like, try to remember that, and now try to walk me through, like, you might think it would be 50 meters per second, but in fact, that doesn't matter because blah, blah, blah. Do you see whenever I say, I hope you understand, what you're trying to show me is how you move from not understanding to understanding. Okay, all right. Anyway, so that's okay. So I'm going to plug it. So we're in step 4 here. Okay, so therefore, right? I mean, so the vertical distance that it's falling, I believe, given the problem, is 125. It's falling down due to gravity. I'm calling down positive. So both of those numbers are positive, and we're solving for t, right? I don't know why I'm in yellow. Okay, I'm saying this fast. I am conscious. I know we only have 8 minutes, so I'm going to really speed this up. But so there's this example, like math is going to give you two roots. You need to explain to me what the other root, they both mean something. The other root, so just in short, that negative root means something physically. It does refer to something real. It's just not what you care about in this problem. You're caring about how much time later will the thing be on the ground. The fact is that math is telling you that it also would have been on the ground 5 seconds earlier if it truly maintained like in other words, if you well, so you got to explain that. And my words are an example, but you're okay. So I'm going to go on because I'm watching the clock. So so here's my final answer circled. The answer to that question A, how much time till the bomb hits the ground is 5 seconds. Now, that's it, right? So that's the answer. Now, of course, there's only 6 minutes left in class, and there's a lot more to the problem. What I'm going to do now, I'm just going to say answer. Like, I'm not going to write this all. You get the point of how you're supposed to explain. I'm not going to explain everything from here on in, but I'm going to just quickly give you answers so you can check your own work or practice. But then you got to follow this model to keep. So now just answers. Okay. I hope that's clear. Like, you got to do more than this in your, but so part B says, how far east from the equator does bomb land? What you quickly, I'm saying, how far across does it land from where it's dropped? In other words, the bomb, while it's falling down, if you look at both axes independently, while this bomb is going down, it's also traveling forward. Why? It came from an airplane that was traveling forward, right? The bomb has now we're talking in the horizontal direction. The bomb does have an initial velocity, just like Lab 4. Okay, I don't want to over explain it, but the bomb is moving forward with an initial velocity. It doesn't have any forward acceleration, but it does have forward velocity. What's the velocity? The velocity that the airplane had, which is it took 8 meters it took 1/10 of a second to traverse 8 meters, just like Lab 4. So the bomb moves forward 400 meters. That's the answer to that. Then C, at the moment the bomb touches the ground, is the elevator cage already there? Yes. Same time. This is, in other words, if the elevator cage was released at the same moment the bomb was released, this is my whole point from 20 minutes ago. The elevator cage just dropped. The bomb dropped while going forward, but going forward doesn't affect the time. So they both hit the ground at the same time. Explain, like you put in your words, but that's what I'm saying. Like same time. Explain. Then D, I know we have 3 minutes. Precisely 6 seconds later, and you got to draw diagrams and all this, or if you're using the same diagram, just say refer to above, blah, blah, blah. But 6 seconds later, a second bomb is dropped. So D is when should bomb number 2 hit the ground? Well, total time from release is the same time. I mean, again, 5 seconds from release of bomb 2, but that means 11 seconds from the original release. right? 5 + 6, in other words. E, where we expect to find bomb two, how far horizontally displaced from bomb one, say another 400 meters. Same thing as before. So these bombs are being spread out on the ground. Each one is going forward when it moves, and it starts ahead of the last one. I'm just going to keep. Okay. Now it's asking a very important thing. I'm going to do on the next page. And you have to think this all through at home. But if now, so the bomb, the plane keeps dropping bombs. The bottom line of this whole problem is you'll know you really understand what's going on, and you'll understand Galileo's principle of relativity and all that. If you understand that basically the picture to F, the answer to F in short is something like this. Oh, sorry. Each individual bomb is moving forward while it moves down in an arc, right? That's the path of one. You could be more detailed in your explanation, but one individual bomb is going forward while it goes down, and it's doing so in a curve, in like a parabola, like your bullet in lab 4. But if you were to take a photograph and think about this later, at any given moment, if you were to take a photograph of what's happening at any given moment, you would see a bunch of bombs um sorry, you would see a bunch of bombs under the plane, all in a vertical formation. And you must think about that at home. They would not be arranged like in a curve or in a curve. They would be arranged in a vertical formation because if you took a picture, not a movie, right? And you can look this up on the web, but like each bomb continues to travel with the plane horizontally as it falls down. So at any given moment, they're all lined up with the plane. And how many would there be? Well, the entire path down to the ground takes 5 seconds. Oh, so this is a little bit weird. I'll probably have to change the numbers for the exam. So there really wouldn't be, I mean, there really, at any given moment, one would hit the ground before the next one would fall. So actually, you wouldn't see that many of them. That's a little bit weird. The numbers aren't great. But the point is, it would be a vertical formation. And that is the end of class, but that's the end of class. I'm going to hang out for a second. If you have any questions, feel free to ask, but you can go. I'm turning off the recording. You've been very patient. Watch the other video, blah, blah, blah. Thank you for your